Hello everyone, my name is Asma Ali, and in this project I built a web server RAID1 storage system using a Raspberry Pi. The goal was to run WordPress on reliable merged storage so the website stays online even if OneDrive fails. Why this project? Website depend on uptime. If storage fails, everything stops. RAID1 merges data to two drives, meaning when fails, the site keeps running. Raspberry Pi give me a low cost and a real server solution I could build and learn from. Why RAID1? Specifically, RAID0 is fast but no protection. One failure and everything is gone. RAID1 duplicates data so failure doesn't stop the site. RAID 5 or RAID 10 need more drives and are more complex. So RAID 1 was the best balance of simplicity plus reliability for a WordPress server. Now I will explain how my project relates to the Raspberry Pi architecture and how 5 core components were used in building the server. First, the ARM CPU. The CPU is responsible for executing instructions and running server. In my project, it's processed a batch with requests, executed PHP scripts, and handle database queries through MariaDB. This helped me understand how the CPU schedules, process, manages multitasking, and responds to the website request in real time. Second, system memory RAM. When WordPress loads pages, plugins, and PHP functions are temporarily stored in RAM. Low memory causes slow response, so it's taught me how RAM affects server performance, caching, and multitasking. This relies directly to class concepts about execution cycles and instruction processing. Third, I/O and USB subsystem. I connect two USB storage drives to create my RAID1 array. This is a perfect example of how Raspberry handle input-output drives. The bus consistently reads and writes data to both drives at the same time, mirroring every block, which depends my understanding of I/O, bandwidth, and hardware communication pathway we studied. Fourth, the file system and storage architecture. The OS boots from the micro SD card, but I later moved the WordPress content to RAID storage. This demonstrated mount points, file permission, ownership, and ext4 general behavior, all things we discussed when learning about storage layers and system control. Finally, networking. My Raspberry Pi hosts the WordPress site and I accessed through the browser via local IP. This showed how packets move through the network interface, how a batch listens on port 80, and how HTTP requests travel from client-server response. So, through CPU, execution, memory use, I/O, communication, file system, and networking, this project allowed me to extend theories from class into a working real-world web server with RAID1 reliability. Procedures: 1. Installed Raspberry Pi OS. 2. Installed Apache, PHP, and MariaDB. 3. Create RAID1 with 2 USB drives. 4. Installed WordPress. 5. Moved WordPress files to RAID for 4 redundancy. 6. Result: My Raspberry Pi successfully host WordPress. HTML, PHP loaded correctly. Website response through the browser. And RAID1 mirrored all data across two drives. Storage become more reliable than micro SD alone. Troubleshooting was one of the most important learning parts of this project. I faced many issues and each one helped me understand the system better. Problem 1: ext4 file system was corrupted and Raspberry Pi could not boot. During configuration, the ext4 file system became damaged and the BI entered recovery mode. I tried many attempts, but the corruption was too deep and the operating system failed to load completely. In the end, the only reliable solution was to reinstall Raspberry OS and rebuild the entire server from the beginning. Although this was time consuming, it taught me that one problem can delete everything. Problem 2. RAID1 array failed to load automatically after reboot. After creating the RAID1 array, it worked one but disappeared every time the BI restarted. The system could not find the mount point and WordPress file were not detected. Then I added the correct UUID and mount configuration to the etc stub file, then set the proper permission. After that, RAID loaded automatically and the storage became mirrored and persistent across reboots. Problem 3. Apache returned 403 forbidden. The site showed an access denied error because Apache didn't have permission to read the files in RAID. To fix it, I changed the file permission and moved WordPress into RAID. After that, Apache loaded the site correctly. These problems were more than just errors. They became learning steps. Fixing them taught me how RAID mounts, how Linux handle permission, how Apache delivers web content, and how to recover when things fail. This experience improved my troubleshooting skills and gave me confidence to solve future issues faster. Lessons learned: Linux permissions are powerful, but can break everything. RAID1 greatly improve reliability. Always move web data off SD card. Troubleshooting teach more than success. Raspberry Pi can act as a real web server. Thank you for your watching. This project helped me understand Linux storage systems and Raspberry Pi as a real server platform. I am happy with this final result and would expand it in the future. With remote access, SSL configuration, and automated backup, I also plan to improve performance, test failure recovery scenarios, and monitor RAID health over time to strengthen reliability even more. Thank you.